So hello everyone, this is C.Sabari from Coimbatore Institute of Technology, currently pursuing my mechanical engineering in CIT. So on today's video, we will be discussing on the topic taper turning methods and thread cutting methods. So without further ado, let's get right into it. So first of all, we need to know what is a taper turning. In order to understand what is a taper turning, let's have a small word on what a linear turn means. So when the cutting tools moves along the line parallel to the axis of the workpiece, so the finished workpiece is always of the same diameter from starting till the end. From starting till the end, the diameter of the workpiece will be the same. There will be no difference in it. So that is known as simple linear turn. So however, when the while cutting a taper, the tool will move at an angle relative to the workpiece axis, so that a taper is produced on the workpiece. Therefore, to rotate the taper, the workpiece must be installed on the lathe so that the axis at the angle to the axis of the lathe, or the cutting tool moves a lathe at an angle relative to the axis of the bend, where the diameter of the workpiece can change uniformly from one end to the another end, and that the taper produced on the workpiece is known as the taper. So taper turning is a machining operation, which means that the diameter of the cylindrical workpiece gradually decreases from one end to the other. So taper can be external or internal depending upon how we give the taper. So if the workpiece is tapered on the inside of the on the inside, it is known as internal taper, and if the workpiece is tapered outward, it is known as outward taper. So let's know what are the methods used for taper turning, and there are various methods out there used for taper turning to do a taper turning in the job, and the most common methods are the following. First one is using a form or a board news tool, uh, tailstock set over method, compound rest method, taper turning attachment method, and combining fade method. So the first one is using a form or a broad nose tool. So here, as you can see, there is a form tool provided right here, which is fed directly to the axis of the rotating workpiece in order to provide a taper surface on the workpiece. You can see the workpiece right there already has a taper, so that the workpiece uh, is produced with a taper while the cutting tool is fed directly into it. So when it is fed directly into the workpiece, the tool used in this method is called a taper turning form tool, and the tool itself is used in a taper shape, creating a tapering workpiece. In this method, the length of the taper should be less than the length of the cutting edge. Since the entire edge removes the metal, it will create a huge vibration and therefore requires a large force. This method is performed to reduce the required vibration and force at a slower rate. So the next one is tailstock set over method, and this is the method where it is commonly used when an angle of the taper is very small. In this method, the axis of rotation of the workpiece is shifted to the axis of the lathe at off an angle to the taper. The workpiece is placed between a live center and a dead center. The tailstock is moved upright in the cross direction, that is in the direction of the lathe axis, by the turning set over method, and the tailstock is locked in an upward or a downward direction to allow the workpiece to tilt, and therefore a taper bend can be performed on the workpiece that is set between the live center and the dead center. And the next method is the compound rest method. As you can see, this is the compound slide. uh, this is the compound slide, which is also known as compound rest. This compound slide can be rotated at an angle. As you can see in this figure, it can be tilted up to an angle of 45 degree. You can't tilt more than that. It can be tilted up to 45 degree, and the workpiece is held in the chuck and will be rotated in the leg axis, and as the tool is fed directly to the workpiece, and taper can be produced in the workpiece. So next one, the taper turning attachment method. This is a quite difficult method. I mean, like, in order to understand, in the next slide I've added a video to give a very more detailed explanation about it. So in this method, the taper bend is performed using an attachment, and this attachment has a guide bar. Okay, this attachment as a guide bar. So this guide bar is usually placed in the center so that the guide bar can swing at any required angle of the taper. This tool moves parallel to the guide bar. The tool provided in this method, the tool provided in this attachment is moved parallel to the guide bar, and a guide bar is used to guide the tool at an required angle, so that the taper of our desired angle can be arrived. So the guide bar has a scale of degrees. The guide bar can be rotated on the both sides at a maximum angle of 10 degree. You can't exceed more than 10 degree, but you can go till 10 degree, not more than that. So the angle required for the taper is achieved by rotating the guide bar in both the direction. In this method, the workpiece are held in a chuck, and the chuck may be 3-jaw chuck or 4-jaw chuck. It is held in a chuck. It has a guide block that attaches to the back end of the cross slide and runs on the guide bar. In this method, the guide bar is set at an angle at which the workpiece is to be tapered. By using this taper turning attachment method, taper turning of any size can be performed easily. This job is either held in a chuck or in the center lathe. For example, let's say dead and live center in tempering process. The depth of cut is given by the compound rest handle. There is a handle provided right there. If as we rotate the wheel, the depth of cut can be given. So let's move on to the video. So this is a very small video to give a brief explanation of it.
This video is about taper turning attachment used in lathe machines. This is preferred in case of long tapers, especially when power feed is to be used.
And yeah, in previous method we might have seen we can only give taper for a small distance, right? But in this taper attachment method, we can give very long tapers, and internal tapers can be bored. And if you are wondering what might be the taper angle is limited to, it is limited up to 6 to 7 degrees.
This video is about taper turning attachment used in lathe machines. This is preferred in case of long tapers, especially when power feed is to be used.
So as you can see,
this attachment has a guide that is fixed along the bend. The guide can be moved to the required taper angle, generally using a screw mechanism. A sliding block is mounted over the guide, which is connected to the cross slide through a pivot joint. Once connected, it is tightened by a clamp. Also, the crossfeed screw must be disconnected or disengaged. So when the carriage moves, the cross slide moves along the guide, which means the tool will also move along the guide. So by changing the guide's position, we can change the taper angle. So that's cool, but how to change the tool feed now that the cross slide is disengaged? Well, that job is taken up by the compound slide. The compound slide can be used to advance the tool post and change the depth of cut as required. Here's a taper turning attachment that I found. This is the guide and its orientation can be changed using a screw here.
You can see that
there are some markings here indicating the taper angle. Hope we could clarify how the taper turning attachment works. Keep watching this space for more videos like this.
So that was the explanation for taper attachment method, so taper turning attachment method. So on further, let's move on to method for thread cuttings. So for thread cutting operation, there are like many methods. So few of them are tapper and die method and lathe operation method. So first of all, let's know how many types of threads are there. So there are two type of threads. One is external thread and internal thread. So where this is, for example, this is the external thread. External thread is also known as male thread, and the internal thread is also known as female thread. External thread is something that where that thread is given on the outer surface of the workpiece, and internal thread is where the thread is given on the inner side. So external thread can be easily found on bolts and that kind of stuff, and internal thread, this kind of thread can be found inside the nut. So tap and die cutting internal threads. So internal threads are made by using a tap. Tap are usually made up of carbon steel or HSS, which is also known as high speed steel, and they are carefully tempered and hardened for a very long period of time, and they are quite brittle and they are easily damaged if they are not handled properly. So let us know what are the types of tap. There are three types of tap: tap a tap, plug tap, or bottoming tap. So first let's know what is a tap a tap. So tap a tap has a quite lot of tapper to it, so which it helps it to easily cut into the threads gradually. Typically the first 8 to 10 threads are tapered. The tap a tap are the most common type of tap, and what what you will be having in a tap and die setup. So as you can see from here, so one, if you count from here until the eighth teeth, there will be a tapper provided, so that at the first it will be a bit easy to cut thread gradually. We can't go straight away with full like zero tapper thread. Even then last one has like 0.5 to 1.5 tapper. We can't just easily go up to like have no tapper, and we can't just perform a thread. So we need a tapper to ease in the process. And the first tapper tap was like 8 to 10 tapper threads, and the second one is plug tap. So as you can see, the plug tap has 3 to 5 threads. Here as you can see, there is from the first 3 to 5 teeth 5 teeths tapper is provided. So plug tap or in between bottoming and tapper taps, because they have 3 to 5 thread tappers, which is more than the bottoming tap and less than the tapper tap. But unfortunately, that the terminology is not always constant. Some people call it as second tap, and some refer to bottom tap as plug tap. So make sure what we are checking for, right? So the last one is the bottoming plug. Yeah, bottoming plug as almost as no tapper at the end, because it is designed to thread all the way all the way to the bottom of its reach. Only 1 to 1.5 will be tapper. I mean, threads will be tapper, as I said before, right? Only 1 to 1.5 threads will be tapper. As you can see, only this first one, and I'm like the first teeth to till the 1.50 teeth is only tapper, and the rest are remaining or the uniform height, so that that thread is provided all the way to the bottom of its reach. Bottoming tap are very useful for threading blind holes. It is desirable to thread most of the holes with tapper tap first, and then the finishing the bottom of the hole with the bottoming tap. So let's move on to cutting external threads. So dies are used to cut external threads by hand, and solid dies are not adjusted, and for that reason soldum is used. This adjustable round die are the most widely used die for hand use. The latter has a wide of adjustment and is fitted with a guide bar to keep it true, and these dies are mostly available for cutting more standard threads. So what are the types of die? So first one is the circular split die and the rectangular half die. So this is the first one. As you can see in this figure, this is the circular split die. As you can see, the die is provided in the center, and there's a stock provided. So here first, with this help of this nut, it is loosened and the workpiece is placed between the teeth and it is tightened. With this help of the stock, if you keep rotating it in the clockwise, it keeps rotating, and there is a bearing right here. There will be a bearing provided. So if you keep rotating that, it will come all the way from up to the down, providing an external thread. As you can see in the rectangle half die too, you can there's two teeth given, and it can be moved up forward and backward by loosening this nut so that it comes all the way back. So the workpiece is placed between this teeth and it is tightened, and by tightening the with this help of this both grips, with the, we grip it by hands and we turn all the way around, and by that means the thread is provided on the external side of the workpiece. And that's it for this video. Hope you enjoyed it. See you on the next video. Thank you.